Hi everyone, a very good afternoon to all of you. How are you all? So guys, we have been continuing our organic chemistry series from past 1 week and we have covered majority of the topics now from 11th standard. 11th standard as of now is almost completed. The final topic from 11th standard is your this part which we call as practical organic chemistry, in which we will deal with some very specific and very important topics that come at the end part of this chapter called as GOC. So it is involving the methods of purifications of organic compound. Then we have some physical processes we'll basically go through. Then we have qualitative analysis of organic compound. Qualitative analysis involves the detection of some important elements of the compound such as sulfur, carbon, hydrogen, and phosphorus, chlorine, halogens, like that. Then quantitative analysis means we have to find out the percentage composition of these elements which are going to be detected in the organic compound. Then we have empirical formula and molecular formula of organic compound and their detections. We'll come to know about it. At last, we'll study some detection of the functional group and their compound. So we'll try to cover all the possible and all the tests which are in our syllabus to detect the functional group, and that is what our chapter is going to be today. So guys, let's start. And so there we have the very first topic, that is the methods of purification. Methods of purification. Okay, I think I'm pretty much audible to all of you, and now we can start the chapter. So methods of purification of organic compound. So first is, once an organic compound is extracted from the natural resource or it is synthesized in laboratory, it's essential to purify it, because whenever it is prepared, it will definitely be containing some of the impurities. Now these impurities could be in any form. They could be in a solution form with this organic compound, or it can be mixed heterogeneously with it. So there are several techniques that will be implemented in order to extract out the pure organic compound. Then we have various methods are used for the purification of organic compound, and all of them are based upon the nature of the compound and the purity present inside it. So guys, I'll give you some of the techniques that are pretty much accepted in order to purify the organic compound. So these are some techniques which are in our syllabus that we have to cover. These processes are called as the processes of physical separations. Number one of them is sublimation, crystallization, distillation, differential extraction, and chromatography. These 5 processes will be taught to you today in this chapter, in this very chapter. So let's start. We have a smaller board today, and I hope everything is pretty much clear to you. So I'll be mostly remaining, I'll keep myself out of the frame in order to make everything visible on the board. It's a smaller board actually today. There we start with the sublimation. Okay, let me get aside first. So guys, sublimation is a process in which one of the thing, either it is purity or it is impurity. Either purity or impurity must be sublimable. The meaning of sublimable means they should directly go to solid to gaseous phase. They must go to solid to gaseous phase directly. So just read it out everyone once. Just read it out. So yes, now we'll come to it. So what is sublimation process? So guys, my notes are very much self-explanatory notes. You can read them, you can learn whatever you want. I will explain everything to you. But always do one thing, right after my class, just download these PPT. This PDF will be downloaded from our Telegram channel and the link is given in the description. And there you can make your own short notes in your own way so that you can revise it quickly whenever your examination days will come up. Sublimation. So sublimation is that technique in which one of the thing, either it is purity or impurity, must be sublimable. That means it is upon heating directly converts from solid to gaseous state. Just take this example of dry ice. Dry ice is solid CO2, and if we heat it or we bring it to the room temperature, it directly gets converted into vapors. So it doesn't leave any liquid behind. It only gets converted from solid to liquid. So this technique is based upon the principle that is known as sublimation. The purification technique based upon above principle. What is the principle? Okay, some solid substances change directly from the solid to vapor state without passing through liquid state. This process is called as sublimation, and whatever the pure compound is there that follows this principle will be used under this category of sublimation and purification. To separate the sublimable compound from non-sublimable impurities, we implemented. Examples must be known to everyone, guys. Examples of sublimable substances you must know. Benzoic acid is one of them. We have camphor, sal ammoniac, iodine. We have sal ammoniac, that is sal ammoniac is nothing but NH4Cl, ammonium chloride. We have camphor. Camphor is camphor only. And naphthalene balls that we use in our household items, and benzoic acid is one of the example of sublimable substance. The another thing is non-sublimable substances. Non-sublimable substances are those which upon hard heating can be converted into liquid state. So what will happen if you heat this mixture? So whatever it is sublimable substances, it will make its vapor, and vapor somehow will be collected over here in this flask, leaving behind the impurity which is sand here. And then you can basically remove this funnel, and you can collect your by condensation, you can collect the solid NH4Cl somewhere else, or solid sublimable substances. This is a very easy technique, and this technique has been what should I say, you already have gone through these techniques, I guess, in 9th or 10th standard. There are also some methods of separations. I think 9th standard we study in NCERT. So this is pretty cool. Second part. Okay, so this is based upon a theory that works in order to bring out the organic compound out of some particular process. So that process I'll give you in a very short way. We have a sample in which impurity and an organic compound both are present. Now what we have to do is, these impurity and the organic compound have different type of solubilities in a given liquid or given kind of solvent. So what are we going to do? We are going to dissolve this thing, and we are going to heat this thing up, or we are going to dissolve in it, so that a true solution is formed there. A kind of saturated solution we'll try to make. So what we'll see, the suspended particle and the one which are not getting dissolved, let it be impurity. That impurity, upon passing the entire solution through a what we call is filter paper, okay, a kind of filter paper. So impurities will be stuck there as a residue, and whatever it passes through is called as filtrate, and your filtrate will be the pure organic compound dissolved in some liquid. And that also upon heating, it is like extra saturated, we call it super saturated. Now if you allow it to cool down, the extra super saturated part will be like separated out as PPT, and upon cooling, some crystals of the organic compound are achieved. So this was the theory behind this complete statement. Now you can read it out. So it is the most common technique, and why, like how is it used? What is the principle behind it? The principle behind sublimation was that one of the impurity or purity should be sublimable. So here, what is the criteria? Based upon the difference in the solubilities of a compound and the impurities in the suitable solvent. Now the solvent could be anything. Sometimes we use carbon tetrachloride for organic compound, sometimes we use carbon disulfide for the organic compound, and sometimes we also use water. If the impurities are also organic, we use water, where our required organic compound can dissolve in water and the another impurities cannot dissolve in water. So the impure compound is now dissolved and the solvent, and it is sparingly soluble at the room temperature but appreciably soluble at the higher temperature. So we'll bring it to the higher temperature so that majority of it gets dissolved, and then we are supposed to pass it, this solution, the concentrated solution gets nearly saturated solution, and upon cooling, the solution pure compound will be crystallized out and removed by filtration. Look at this, everyone. Let me get aside. Please go through it and read this out. Just have a look. How is it working? So just go through this process and try to make this process, note this process down in your notes so that you will be very much comfortable to recognize this, because whenever we draw something, we write the complete diagrams of something. This can be easily rememberable and we can recall it anytime we want. Okay, so now let me get you to what is happening here. So initially what do we have is, what is it, evaporation? Okay, anyways, what we have is some particular solvent with us. This impure organic compound is dissolved here. We know that only organic compound, pure organic compound will be dissolved and impurities won't. We are passing this hot concentrated or saturated solution through a fluted filter paper. Fluted means it's a cone shaped filter paper. We have a technique to make this cone. You might have performed these experiments in your school level. Then after passing it, something will be left there as impurity. So let us suppose after passing this, something has stuck here and it is not passing through the filter paper. This is your impurity, and this impurity is called as residue. Impurity is called as residue. And whatever it is passed through, it's a filtrate, and filtrate contains what? Pure organic compound dissolved in that particular liquid. So right after cooling, if you cool this particular thing down, upon cooling you will get the crystallization process, and crystals will be separated out of pure organic compound. This kind of phenomenon, this kind of procedure works on this principle that there should be different kind of solubilities of organic compound and the impurities involved in it in a particular suitable solvent. So that is how it works. Now let me take you to another important term called as distillation. So take the idea of distillation. How does distillation work? Distillation is a process which is actually based upon this principle that two liquid or two kind of substances which are mixed together, one of them is an organic compound, another one is the impurity, or let it be a mixture of two different organic compounds which we need to separate out, like benzene and toluene are there, or chloroform or aniline are mixed together. So in such a condition, what we do, we heat them up to a temperature which is like in between of the boiling point of these two. In between of the boiling of these two, one of them will be getting boiled up. The one which is getting boiled up, will be separated in the form of vapors. The another, which is having higher boiling point, will remain here in this flask itself, and that is how we collect the two components. So simply let us go through it. Number one point is, yeah, so this is important method. Now it is fine, I guess. I don't think it's needed. I should turn these lights off. Wait. Now it's fine. So guys, what I'm telling you, distillation, we are right now discussing about the distillation. Distillation is a process in which we have two liquid form substances, organic compounds, and one of them will be having a lesser boiling point than another. So we are supposed to heat the mixture as a like in a intermediate boiling point, intermediate of these two boiling points. So what will happen? One of them will be the one which is highly volatile will go here like the vapors. The vapors are basically passing through it. We have a condenser, and we also call it cooler. So this is providing cooling effect to the vapors, and then they will be condensed down into another substance, another beaker. You can collect it. This is what the basic working of distillation is. But this works only when there's a delta of boiling point, when there's a delta of boiling point greater than 40 Kelvin or 40 degrees Celsius. Whenever there's a degree, there's a gap beyond 40, then this technique is very much suitable, then this technique is very much applicable. But we will face problems when we have boiling point lesser than 40 Kelvin. So let us suppose among these two component A and B mixed together, delta of boiling point is less than 40 Kelvin. So what will happen? Majority of the vapors will contain both of the liquids. Both of the liquid as in A and B, both will pass as a vapor. Even the condensed form or the collected form will also be containing both of the liquids. So what should we do, by the way? What should we do in order to carry out the multiple number of distillations? What we should do? We put some device called as fractionating column. This device is called as, where is it? These are called as fractionating column. We call this device as fractionating column. So this column consists of either glass beads or somewhere there are bubble of glass which are made, and then it allows multiple times condensation, evaporation, condensation, evaporation. So the one which is more volatile will anyhow leave this thing out and will be going through this side, and then after cooling or after condensation we can collect the more volatile substance somewhere else. And the lesser volatile with the higher boiling point will be condensed right now in this process multiple times and will be condensed down in the same container which we have started with. So that is how we do. Now it comes fractional distillation. So let us read it. Whenever there is a difference of boiling point of 2 is not too much, like near to like less than 40, and we need to separate them, then we implement a fractionating column. And in this technique, vapors of a liquid mixture are passed through fractionating column before condensation. So a fractionating column provides many surfaces for heat exchanges between the ascending vapor, sand and vapors and, these are two different things, vapors and descending condensed liquid. So multiple time, you can say multiple time distillation is occurring, where evaporation and condensation is happening at multiple stages. And right after that, what will happen? After a series of successive distillations, the remaining liquid in the distillation flask gets enriched in the concentration in higher boiling point component. One of the technological application of fractional distillation is to separate the different fractions of crude oil in petroleum industry. I'm star marking it because these kind of questions have been asked previously. We must know what is the application of what kind of technique which we are studying. Different type of distillations have different type of application. Just look at this fractional distillation. What is the major purpose of fractional distillation? It is used in order to separate out the components of crude oil in petroleum industry. Okay. Seems like yeah, hi Vivek, hello Sumesh. How many hours will it go? Well, it won't take too many of hours because we have already discussed the plan in the beginning of the lecture. We have some sort of separation techniques with us. Then later on we'll discuss about the qualitative and quantitative analysis of organic compounds. Then we'll go for finding the percentage compositions of this compound and calculating their, what should I call it, molecular formula, empirical formula, like that. And at last I'll give you some of the tests of functional groups, just like Victor Meyer test and Lucas test and blah blah blah. So many tests are there that we'll discuss. That is it. We have this complete process where you can understand what is happening here. In this fractionating column, multiple times condensation evaporation occurs, and the more volatile with lesser boiling point will be separated out as vapor. We are having a condenser which is actually doing the cooling part. After cooling is condensed and we collect it in the separate vessel. That is what the working of fractionating, fractional distillation, a specific type of distillation. Next is distillation under reduced pressure. Distillation under reduced pressure. When should we implement it? Okay, so every single type of distillation I'm teaching you, it has its own application. So let me just give it a number once. So we started distillation from here. Now let me say fractional distillation number 1, where the difference in boiling point is very less in order to basically separate the components of crude oil. Number 2, we have distillation under reduced pressure. There are some compounds which kind of like dissociate when we reach to their boiling point, and one of the these compound is glycerol. So glycerol, whenever it is heated up to its boiling point to make the vapors, this gets dissociated into further compound. So what we have to do is we have to maintain, we have to increase its boiling point, increasing its boiling point by increasing the external pressure. What is the definition of boiling point? A liquid has its boiling point by that temperature at which its vapor pressure becomes equal to the atmospheric pressure. Now, what if we increase the atmospheric pressure or the external pressure? Then its boiling point will be definitely be increased. So that is what technique we have to follow under distillation under reduced pressure. Now, please read it out. This method is used to purify the liquid which have high boiling point. No. Liquid having very high boiling point, so that they decompose at or below their boiling point. They dissociate easily. So such type of liquids are made to boil at lower than their normal boiling point by reducing the, okay, we're reducing the pressure or what? Okay, got it. So what we are doing is, mistakenly said that we are increasing the pressure. We are actually decreasing pressure. What is the benefit of that? If you decrease the external pressure, their boiling point will be decreased. If their boiling point is decreased, they will not break down and they will boil soon. So they will make more vapors. So that is what we have to follow under distillation at reduced pressure. The name itself says the reduced pressure means decreasing the pressure. So liquid boils at temperature at which its vapor pressure is equal to the external pressure. If external pressure is reduced, then its boiling point will also be reduced. One of the very good example of such method is this, and I'm star marking it. Glycerol is one of the substances which is used in soap industry in the saponification process, where alcohol and acids are reacted together forming the salts of the fatty acid. Salt of the fatty acids are called as soaps. So in order to prepare the soap, we prefer this kind of reaction where glycerol can be separated from spent lye. Spent lye is actually the whole mixture there in the soap industry by using this technique. So do remember it. We are not supposed to learn down or learn down this, what is the boiling point and at what temperature does it break. No. That is a purely theoretical thing. We are not supposed to learn down. We must know the what procedure we are following, and if in examination some example have been asked, or one of the option is this like related to the glycerol, pick it. So two type of distillation we have completed till here. We have third type of distillation called as steam distillation. The name itself suggests that we are gonna to pass steam, which is actually vaporized form of water. And why we are passing steam? Because one of the component will be basically dissolved or vaporized by passing this heat, This basically is steam, and another will stay there. So this is what mechanism will be followed. But first of all, let us know where can we implement it. What is the mechanism behind steam distillation? What is the principle of steam distillation? Where we have to implement it? So this technique is applied to separate the substances which are steam volatile and are immiscible with water. So there are two things which are going to happen. One of them is a compound should be steam volatile. That means it once it gets once it gets in the contact with steam, it gets evaporated easily. The moment it gets evaporated, it will not be even mixed with water. So right after that, it will be going somewhere with the steam and it will be cooled down and collected somewhere. Since it is not miscible in water, it can be easily separated out from water using a separation technique. We call it separating funnel. So in steam distillation, the steam of a steam generator is passed through the heated flask containing the liquid to be distilled. The mixture of steam and the volatile organic compound. Volatile organic compound is the one with lesser boiling point. So guys, we need to learn first of all what is the principle behind this technique, why are we implementing this technique. Number two, what we have to learn is after this part, you should know, even we all should know, that which technique should be used where. What are the particular examples, because in question or in the examination, whenever some question have been asked related to this process, they will definitely ask where to implement this or not. I also have a plenty of questions to discuss with you, so just be prepared and learn everything concept wise, where something is used and why. So the perfect example, so aniline is separated by this technique from aniline water mixture, and also ortho and para nitrophenol can be separated. So guys, just look at this. Ortho and para nitrophenol. So guys, this has higher boiling point and this component is more volatile. This is called as orthonitrophenol. This is called as paranitrophenol. Hopefully this is very much clear to all of you. So we have discussed three types of distillation processes here. Next one is called as differential extraction, and this is your fourth technique which we are studying. We studied this is the third technique we are studying. Third or fourth? Fourth. We at initial studied one. Sublimation is one. We had crystallization, another, distillation, and now fourth is your differential extraction. One of the very easy technique that we use, and this is what we use even in our homes also. Someday you might have seen this part that at our home, whenever our mama cooks the rice or some what should I call it, dal. So what we do, this rice and pulses and all, they mix it, and while making the khichdi and all, and we soak it in the water. So because of their high density, they sink, and because of the lighter density of water, the lighter impurities come up at the surface of water and start floating there. So we separate the water, this impure water, slightly, so that under the influence of gravity, water flushes out the impurities, and remaining part remains there. Pure part remains there in the form of rice and pebbles. So now what we have to understand, the same process is used in the differential extraction. We have a device, this kind of very beautiful looking device. This beautiful looking device is called as separating funnel, because this will separate out two components. This is called a separating funnel. So separating funnel will do what? Let's say there are two things. One of them is organic, another one is inorganic, and they are not dissolved in each other. So the one which is heavier will just open this cork, and we will just remove the first part, and we'll wait until the first part gets over. Then we'll screw tight it, and then we'll preserve the another one. So it is very easy, guys, if you can understand it. Like oil and water, if we mix, oil is lighter than water, and oil comes up over the surface of water. So we can remove water by this process, and then later on we can separate the oil. So how easy is this process, guys? Now read it out, everyone. So when an organic compound is present in an aqueous medium, it is separated by shaking it with an organic solvent in which it is more soluble than in water. The organic solvent and this aqueous solution should be immiscible with each other. And so this is actually based upon what principle? The principle is pretty cool, pretty easy, that pure and impure substance must be immiscible. That means immiscible means they should not be getting mixed, and they should not get dissolved. They should not make a true solution. Hopefully this is very much clear to all of you. And if not, then please read it out properly. Try to make the short notes right after this lecture. Okay, now I'm bringing you to the another final technique, fifth technique, called as chromatography. Now please read it out, very important one, most important one out of all the given techniques. Anyways, so there we go. So we have chromatography. The name itself suggests chroma stands for color. Chroma stands for color, and graphy stands for measure. Measure of plotting. So chromatography is a very important technique extensively used these days in order to separate the mixtures of where we are supposed to use it? Separating the mixture of the component to purify the compound and also test the purified compound. And also to test the purified compound. Guys, this technique is actually nowadays used in the chemical laboratories and also in order to give you the what should do like blood tests we do. So many dissolved components of a particular liquid can be identified using this technique, and there are like so many things which we do under this. There could be column chromatography, there could be adsorption chromatography, there could be like different type of chromatography is there, adsorption. So we are supposed to learn every single one. Let us see. So Greek term chroma means color, and let's see. So in this technique, a mixture of the substances is applied on a stationary phase, which may be a solid or a liquid. We'll read out everything singly. Simply, the mixture of substances is now applied on a stationary phase, and which may be solid or liquid. A pure solvent is which is a mixture of solvents, or it could be a gas also. It is allowed to pass slowly over the stationary phase, and the components of the mixture, they gradually get separated from each other. And the moving phase is called as the mobile phase. Stationary phase and mobile phase, there are two things which we have here. What is wrong with this website? Now the components of the mixture, they are separated from each other. The moving phase is called as mobile phase. The stationary is called as stationary phase, based upon the principle that based on the principle involved, chromatography is classified into two things. So what is the principle basically? Principle is like a different extent of reacting or kind of like getting dissolved in the mobile phase, and reaction of the individual substances toward the mobile phase. So number one is called as adsorption chromatography, another one is called as partition chromatography. We'll one by one study both of them. First we have adsorption chromatography. The name simply suggests that different component will try to adsorb over the mobile phase, and let's see how does it work, by the way. First of all, we have, it is based upon the fact that different compounds are absorbed on the adsorbent. Adsorbent is a substance upon which we are carrying out this particular adsorption process, and up to different degree means different extent of adsorption takes place for different components of the compound. Commonly used adsorption is adsorbents are silica gel or alumina. When a mobile phase is allowed to move over stationary phase is actually your adsorbent. Okay, so adsorbents are actually your stationary phase. So then what happened? The mixture move by, so varying the distances over the stationary phase, and following are the main types of adsorption chromatography that we study. One of them is called as column chromatography, another one is called as thin line chromatography. Believe me everyone, this might sound you a bit difficult, but actually it is not. It is very easy, and I will help you understanding the complete concept. So not a problem. I'll give you a simpler version of this entire theory which you are right now studying. I'll give a very simple version of this theory. So let us first come to the column chromatography. So you better read it out once, and then I'll give you a clarity about this concept. You first read it out everything, and then I'll give you the clarity how does it work. Finally, chalo. Now let me take you to this column chromatography. So guys, you might have gone through every single thing here, and let me just explain the part to you. So what we are right now having with us, we have a set of column here, and this column is actually filled with some solid silica gel, let's say. So solid silica gel is working as a stationary phase. Right? And we also have one thing here. So we are having our like A plus B plus C plus D, and these are all dissolved in solvent, some suitable solvent, some organic solvent. And now we'll pour this thing over here. So this will this itself is working as a mobile phase. This is working as a mobile phase, and the one this is working as a silica gel is working as an adsorbent and also as a stationary phase. So whenever this is passed through it, what we'll see, separate layers will be formed. Let's say this is your A, this is your C, this is B, and this is D. So what we can see that the extent of our adsorption is, which one is getting more adsorbed, extent of adsorption. Which is absorbing more? The one which is going farther. Let me check. Depending upon the degree to which compounds are adsorbed in the complete, the most readily adsorbed substances are retained near to the top. So the extent of adsorption will be A is maximum, then C, then B, and then D. Since D is least adsorbed, it is going at the end of this column. So now right after that, you can separate the silica column. You just cut them out and dissolve them in suitable compound where silica gel will be will be removed out, and organic compound will be separated as a solution form. This is how we use it. So that was one of the way called as column chromatography, and that was based upon the fact of adsorption. The major principle working on this is adsorption. Then we have TLC, the most common chromatography used these days. TLC is known as thin line chromatography. Thin line chromatography is nowadays used for blood sampling and some sort of chemical analysis. We use it. So let us see how does it work. So thin line chromatography, TLC, is another type of adsorption chromatography only, which involves separation of the substances of a mixture over a thin layer of an adsorbent coated with glass plate, coated on a glass plate. So see, this is a glass plate, everyone, and this is your stationary phase, by the way. This is a glass phase, and this is actually silica gel and glass phase. It is written. It is an adsorbent coated on the glass phase. So we have a sample dot. The meaning of sample dot is, this is the sample which is containing so many chemicals in it. Let us suppose this dot be your blood, and we are trying to check it out, the doping test we are carrying out, and we want to check what drugs or chemicals are present in our blood. This is your blood sample. Then we have a solvent here. This solvent is actually working as a mobile phase, and your glass plate is working as a stationary phase. So this starts going up with its capillary action. The plate is known as the TLC plate or chromatographic plate, chroma plate. Okay. The solution of the mixture to be separated is applied on a small spot at around 2 cm above one of the end of the TLC plate, and the glass plate is then placed in a closed jar containing an eluent. So what is the eluent? Eluent is the liquid that can climb up with adsorber or adsorbent surface, which can climb up with adsorbent surface. This is called as eluent. Eluent is a fluid and this fluid is actually nothing but the solvent which is we are considering as mobile phase. So now this mobile phase will rise up, and with this mobile phase, this dot or the number of components involved in this dot will be separated out and will start climbing up depending upon the adsorption extent of adsorption. So what will they do? Different component will have a different value of RF, which is called as retardation factor. So retardation factor can be calculated at distance traveled by the substances from the baseline upon distance traveled by the solvent from the baseline. The solvent is your eluent, and this substance is actually the component which we are discussing in the blood sample. Let's say in blood sample some kind of drug has reached to some extent, so we can find out which one of them is more adsorbent or which one is not easily adsorbed, like that. So read it out everyone, and then we'll come to questions. Now, then we have one more kind of chromatography. My notes are entirely based upon NCERT because this portion has been asked from either of your NCERT or the lab manual of your NCERT. So lab manual also is very important because majority of the questions from the lab manual will come in this practical analysis. I have segregated these into two segments. One of them is organic chemistry, another is inorganic. Inorganic will deal with the end portion which is given in the NCERT GOC part, and other in the another segment will deal with the salt analysis and all. So let us read it first. Partition chromatography. Partition chromatography is based upon the continuous differential partitioning of component. Okay, continuous differential partitioning between the stationary and mobile phase. I don't know what is the meaning of that. Let me just get through and clearly. So paper chromatography is a type of partition chromatography, which you are right now is a partition chromatography. In a paper chromatography, a specific quantity of the paper, which is a special quality paper called as chromatography paper, is used, and chromatography paper contains water trapped inside it, which acts as the stationary phase. Okay, we have a strip of chromatography paper spotted at the baseline with solution of the mixture is suspended in a suitable solvent or mixture of the solvent. Now we are supposed to dip this inside the solvent. So now this will start climbing up. With the climbing up, this spot which is containing so many like basically component inside it, they will also move along with this paper. This is also a kind of paper chromatography only, but this is called as partition chromatography. So how is partition taking place? The components of this dot are basically have come over this. We can cut this down, I think, and then we can separate. Let me read it. So the solvent rises up through the paper by capillary reaction and flows over the spot. The paper selectively retains different components according to their different partition in two phases. The paper strip so developed is known as a chromatogram. The spots of the separated colored compounds are visible and they are different heights. So from the position of initial spot on the chromatogram, the spots of the separated colorless compound may be also observed either under ultraviolet light or by the use of an appropriate spray reagent as discussed under the chromatography. So that is what we do. That was pretty boring, but I can give you a quick solution for this. We have some set of sample here. We have put it as a dot. This dot has many components present inside it, and whenever we use a proper solvent and this solvent start climbing up with the capillary action, and this particular partition which we are seeing, so many components are separated with different positions of there, and that's how we separate them, and we call this particular measurement, or we call this particular arrangement of different components on one white paper sheet as chromatogram. I guess that is it, everyone. That is it. Anyways, now is the time that we should start solving some questions on whatever we have studied. This might be a boring topic. For this boring topic, I have picked some very good questions to revise every single thing which we have discussed till now. There comes the first question, everyone. Be energetic, stay energetic, and let's solve some questions. Best method and the latest technique of isolation of the purification separation of the organic compound is what? Yes, chromatography. Very basically efficient and very precise technique that we use these days, called as chromatography. Next, a mixture of oil and water can be separated. See guys, whenever two substances are not miscible to each other, two immiscible substances can be separated using a separating funnel, because separating funnel can have different densities of these two component. One of them will be sink, one of them basically one of them will lie above another, and we can separate them using the separating funnel. That is what I think. Now let us check the correct answer. I thought so. So guys, buddies, please participate and you can also pick your correct answer. Separating funnel is the best answer. Next question. In crystallization, the compound dissolved in a solvent is more soluble than in what temperature? I'm not getting what is this saying. In crystallization, the compound. Okay, we knew that a compound, especially which is an sparingly soluble salt under normal condition, on heating it gets dissolved very easily, and right after the experiment is conducted, it gets separated out as on cooling as crystals. So I think higher temperature is the correct answer. So higher temperature is the correct answer, in which we dissolve the given sparingly soluble salt in the water or some solvent, suitable solvent. Next question. Identify the examples of the separating steam distillation. Guys, you all know steam distillation. One of them should be what? I remember steam distillation is followed where one component is steam volatile and immiscible in water. It should be steam volatile, but it should not be mixed with the water. I don't remember where were we. Okay, aniline water mixture. Aniline and water mixture can be separated out. Aniline and this can be separated out. Next question. We have next question. Okay, there we go. Okay, now let us come to the another second part of this lecture, which is qualitative analysis of all the components present inside the organic compound. We all know that organic compound, the major constituent of organic compounds are carbon and hydrogen, which are hydrocarbon, and all organic compounds are the derivatives of hydrocarbon. So how to basically detect? So carbon and hydrogen can be detected using this process, which is a very easy process, everyone. Very easy process. What we do? We heat the entire organic compound in presence of cupric oxide, CuO, and on heating there are two important compounds which are formed. Carbon forms carbon oxide, and carbon forms carbon oxide by reducing copper, and hydrogen forms water by reducing copper. We all know that in our electrochemical series, copper comes at very at the bottom, kind of like even below hydrogen it comes. So undoubtedly carbon will be, sorry, copper will be reduced. Then in next step, what we do, we make these two things react with CO2 gas. Wherever it is passed the CO2 gas, we get it reacted with calcium hydroxide, and calcium hydroxide is called as lime water, and we say generally lime water turns milky. So how does it turn milky? By preparation of calcium carbonate, which is actually a solid suspended PPT in aqueous solution, and this is also like a slightly dissolved there, and with the formation of water. So this lime water turns for milky. This has the milky appearance, whitish appearance. The next one is we have water. So guys, water is reacted with copper sulfate and hydrous. So this is solid. After getting reacted, it forms CuSO4.5H2O, which is called as blue vitriol. So blue vitriol has a blue appearance. So now this is how we confirm it. This is how we confirm the presence of these two important compounds. So do let me know if any doubt you are facing in the comment section. Next we have detection of the other elements. Another beautiful part, detection of other elements, such as we have nitrogen, sulfur, halogen, phosphorus, and these all can be detected using Lassaigne test. So Lassaigne test is what? We prepare a compound with sodium, we react, because sodium is most reactive element, and we make organic compound to react with sodium, and sodium usually prepare or usually make compound with every single element. So like in case of carbon, sodium can make carbide, or carbon and nitrogen it can make cyanide, or carbon, nitrogen, sulfur it can make thiocyanate. This kind of compound it makes. So let us see. Sodium alone with carbon and nitrogen forms sodium cyanide. Sodium with sulfur forms sodium sulfide. Sodium with halogen forms sodium halide, NaCl, NaBr, NaI, like that. So right after that, once the extract is ready, we have proper procedure where we can find the presence of sulfide ion, cyanide ions, and then halide ions, like that. So first of all, we need to prepare a Lassaigne extract. Number one test for nitrogen. We'll conduct the first test for nitrogen. How are we going to conduct the test for nitrogen? The sodium fusion extract that we right now have got, it is boiled with iron 2 sulfate. Okay, FeSO4 it is boiled with, and then it is acidified with concentrated sulfuric acid. The formation of Prussian blue color confirms the presence of the nitrogen. So this is how the reaction takes place, everyone. Cyanide, when reacts with Fe2 plus, it forms a FeCN whole 4 minus, and that FeCN whole 6 4 minus, when reacts with iron 3 positive, we get Fe4 FeCN6. This is called as, let me write it, everyone. This is called as Prussian blue. The color itself is Prussian blue, and the Prussian blue has a chemical formula of this is +3. Outside is the +3, and I said inside it is +2. Yeah, so this is called as ferrocyanide. This compound is called as ferrocyanide. Ferrocyanide. So guys, we have Prussian blue called as ferrocyanide, and this confirms the presence of cyanide. Okay, so what is the chemical reaction which we are doing? Initially we had ferrous sulfate. Ferrous sulfate, when reacted with concentrated sulfuric acid, uh, it is oxidized to Fe3 plus. Then some of this Fe3 plus reacts with the complex formed by the cyanide and Fe2 plus, and then it forms the Prussian blue, and this is how it looks like. Now, hopefully this is pretty much clear to all of you. Next, we are conducting the test for sulfur. So guys, sulfur, if alone sulfur is there in the hydrocarbon along with carbon and hydrogen, we already have conducted the test for carbon and hydrogen. We already have known about the carbon and hydrogen. Now, if we have organic compound containing sulfur, then we already had this with us, which is called as sodium sulfide with us, which gives you sodium ion and sulfide ion. So let's say this is aqueous. On dissolving, we are getting aqueous this. When you pass this through lead-2 positive ion or PbCl2, let us suppose aqueous, then this will be converted into PbS, a black PPT, a black precipitate. This will give you a black precipitate. That was one test. That was one test that we studied. There are many more. Okay, next is, so now on treating the sodium fusion extract with sodium nitroprusside, this is one test for sulfur. We are doing another test. So another test is when on treating sodium fusion extract, which is sodium, this is your sodium extract, or this is basically sodium extract or sodium fusion extract which you are talking about. When this sodium fusion extract is reacted with sodium nitroprusside. So what is sodium nitroprusside? This is called as sodium nitroprusside. Why are we calling it nitroprusside? We all know Prussian blue. What was Prussian blue? That was ferrocyanide, and this is a compound where nitroprusside is actually a compound in which iron is in positive 2 oxidation state, 5 cyanide is there, and 1 NO plus is also there. NO contains a NO, nitrosyl ion. So plus 1 is this, and plus 2, 3 minus 2, correct. So NO with a plus 1. Okay, this let me just give you this idea. It's an important thing. We must know that this NO contains a NO with a positive charge. It's a ligand. Nitronium ion. Nitrosonium ion, we call it nitrosonium. So please read it out, everyone. Please read it out. If it's visible and if not, I'll read everything for you. Download the notes and get the idea. Now, so in the case of if there is a nitrogen, okay, so now this thing becomes violet in color, and initially we had just sulfide ion as a colorless ion. On adding this sodium nitroprusside with no color, it has become violet in color because of the presence of NOS ion. Because in the presence of what? It makes you NOS minus ion. This is called as another ligand, NOS minus. Okay, and nitrosonium was there in the NO positive form. So another thing is there that if apart from sulfur, if nitrogen is also there, so like see carbon, nitrogen and sulfur, they form sodium cyanate, okay, thiocyanate we call it. So sodium thiocyanate it is forming, and sodium thiocyanate on reaction with iron 3 plus, these SCN minus ions on reaction with iron 3 plus combines and gives you what? FeSCN2 plus complex, which is blood red in color. So guys, this blood red, actually it is, this process is also used to make the fake blood in movie industries. This is the fake blood, and this blood red test is this color is appeared when we have thiocyanate ion with iron 2 plus. Okay, so it's a very important part to learn. Very important part to learn. Then we have sodium fusion is carried out with excess of sodium, and the thiocyanate decomposes to yield cyanide and sulfide. Okay, so these ions give their usual test. So let us suppose there is one more thing which we can do. So we already have SCN here. So if we heat it in the presence of more sodium, then it forms sodium sulfide plus sodium cyanide, and then they give their usual test, like sodium test is here, and cyanide test we have already covered on reaction with Fe2 positive and then getting concentrated H2SO4 Fe3 plus, and they will produce what? Prussian blue. That test is already done. Next is test for halogen. So the best test for halogen after this Lassaigne extract which we are getting is treating with aqueous AgNO3. What does aqueous AgNO3 contain? So we already have NaX here, which is actually Na positive, and all of them are very much dissolved in water, forming aqueous solution Na positive. And let us suppose halide ion is here. So one of the halide ion, let us suppose these are passing through the AgNO3 solution, aqueous. So they will form AgX as precipitate. So how do we identify them? Let's say AgF is actually soluble in water, no PPT. So we can identify fluorine from here. If AgCl is there, we can have white PPT. If we have AgBr, we get a pale yellow PPT, slightly yellow. And in case of AgI, we have a dark yellow PPT. Dark yellow PPT. So that is what the test we do for halide ions. So halides are very easy to detect with, very easily can be detected. Please read it out, everyone. So this is where we have completed it till here. Okay, now we'll move forward. So let us just read it out once. We had sodium fusion extract acidified with nitric acid. So acidified with nitric acid and then treated with silver nitrate. So what does, so if any other impurity is there, that will be oxidized by the nitric acid and will be removed there from there. A white precipitate of soluble in ammonium hydroxide shows the presence of chlorine. Okay, there is another test which we are conducting. What we are doing is, we initially had NaCl, let's say, and NaCl with reaction with anyways, yellowish PT is there. What reaction are you doing? Silver nitrate. Sodium fusion extract is acidified with nitric acid. Okay. So sodium will make NaNO3, maybe kind of reaction. Then let us suppose if nitrogen or sulfur is also present in the compound, the sodium fusion extract is first boiled with concentrated nitric acid to decompose the cyanide or sulfide of sodium formed during the Lassaigne test, and these ions would otherwise interfere with the silver nitrate for the test. Okay. So what we are doing is, if nitrogen or sulfur is also present in the compound, then first the sodium extract has to be first boiled with concentrated nitric acid to decompose the cyanide or sulfides of sodium formed during the Lassaigne test, and these ions will be otherwise interfering in the silver nitrate for the test for halogen. The silver nitrate test is quite easy here, which I have written down, and the presence of other ions can interfere it, like silver can also react with sulfide ion forming the Ag2S. Silver can react with cyanide forming AgCN. So we are supposed to remove the ions of sulfur and sulfur, or let it be cyanide ion. So whatever the ion is there, and whenever they are treated with concentrated HNO3, it oxidizes them, and it oxidizes and get them converted into their volatile products, such as sulfur may be converted into SO2, may be removed down. Cyanide may form the oxides of carbon and nitrogen, because concentrated HNO3 is a strong oxidizing agent, and some volatile gases will be produced and they will be removed from there. And rest remaining halogen doesn't react with nitric acid forming any volatile compound, and that is why these halide ion will be reacting with Ag plus, giving you this test. So this is what the explanation is about. Fourth is the test of, now we have the test of phosphorus with us. Tests of phosphorus. So the compound is heated with oxidizing agents such as sodium peroxide at first. The phosphorus present in the compound is oxidized to phosphate. The solution is boiled with nitric acid and then treated with ammonium molybdate. Yellow coloration is appeared. Okay. Anyways, let us go through this. First of all, what we are doing is, we, let us say, already have a sodium phosphide with us, which is treated with sodium peroxide. The compound is heated with oxidizing agent. So we are directly carrying out this reaction. Let's say we have the organic compound directly with us. Note the sodium extract, organic compound. That once treated with Na2O2, sodium peroxide, produces. So this has a compound phosphorus present in it. This phosphorus will form sodium Na3PO4, sodium phosphate. This sodium phosphate will be later on reacted with concentrated HNO3, where it gets converted into H3PO4. It forms the phosphoric acid H3PO4, and it also forms sodium nitrate. So it's a kind of like double displacement reaction occurs. It's a like kind of double displacement reaction. This on reaction with ammonium molybdate. This on reaction with ammonium molybdate and concentrated HNO3 produces a compound called as ammonium phosphomolybdate. Ammonium phosphomolybdate, which is NH4 whole thrice ammonium phosphate dot 12 MoO3. So ammonium phosphate and molybdate. So guys, this compound which we are seeing is a yellow colored PPT. It's a yellow color PPT and confirms the, it's a yellow color precipitate and it confirms the presence of phosphorus. Now please read it out. I'm getting aside. Please read it out. So whenever you make your own notes or short notes, do one thing. Write down the complete reaction and make sure everything should be in short. No need to require the complete procedure, what boiled and what done. Simply write the chemical reaction and understand that sodium phosphate was first prepared by treating the organic compound. So we didn't have sodium phosphide when we reacted and we will Lassaigne test was carrying out. We directly reacted the organic compound containing phosphorus with Na2O2 forming Na3PO4, which was later reacted with concentrated HNO3 forming the double displacement reaction H3PO4 phosphoric acid, that upon reaction with ammonium molybdate produces ammonium phosphomolybdate, which is yellow colored PPT. That's it. Next, we have some questions which we have just discussed. So what test is basic? Okay, no, this is a wrong question actually. We haven't gone through these tests now, but anyways we can do it. So we have yeah. So Lucas test is done for, I told you a few days back, maybe, or we'll cover it in the 12th class, we covered it in the reaction mechanism also, that Lucas test also follows the SN1 reaction, and alcohols are treated with concentrated HCl and ZnCl2, producing the haloalkanes, which are turbid in color, up in appearance. We have Dumas test, and Dumas test is done for. Hinsberg test is this, which is basically benzyl sulfonyl chloride and aqueous KOH, done for separation of the amines, primary, secondary and tertiary. Dumas and Zildal, we have two things here. So one is D and 1 is D and 4 is A. 1 is D, 4 is A. I guess this is the correct answer. So remaining third Zildal method will be Zildal's method. We reacted with the H2SO4. We'll come to it. Reaction of H2SO4 with the ammonia or the nitrogen, which is converted down into ammonia and then reacted with it. We'll come to it. It is used in the quantitative analysis. We will study this in the quantitative analysis. Similarly, the CO and CO2 will be used for now Dumas method will be used there. This is Zildal's method. Dumas requires what? C. Right. This is C, like this. Anyways, now come the Prussian blue color obtained during the test of nitrogen by Lassaigne test is due to the formation of Prussian blue color obtained during the test. What is it by? So that was ferrocyanide. So ferrocyanide is there, guys. So ferri is Fe3 plus and ferro is Fe2 plus with a complex of cyanide and octahedral complex like this. So understand, guys, this will be having a 4 minus charge. This will just cross multiply with their charges, and this is how we get the formula of Prussian blue. This is your Fe4 FeCN6 whole thrice. Check it out first. Next question. So when we were carrying this test in the Lassaigne test, one of the organic compound gives a red color with FeCl3. What is this compound be? So no doubt we remember that sulfide ions, no, not sulfide ion, SCN ions was there. Right. So I remember SCN minus ion on reaction with Fe2 plus, sorry, Fe3 plus gives a compound like this, which was blood red in color. So the correct answer, where can you find this this ion? SCN minus ion in over here, right? Or you can take this whole compound also. This compound is basically, let's say it's an organic compound. So this is how it look like, that NH2 C double bond S NH2. So guys, on reacting this compound with sodium and doing the fusion, so this will form sodium SCN, and then with Fe3 plus forms an FeSCN whole thrice. This is a blood red color complex. That's how we do. So now we have, guys, quantitative analysis with us. Quantitative analysis will involve mathematical calculation of the percentages of these things available. Okay, so now, so guys, now we are conducting what? There we are having the quantitative analysis will measure the percentage. So any kind of thing you want to know, so percentage composition will be equals to mass of the element that we are talking about upon mass of the organic compound given to us into 100. That is what we use everywhere. So let us just start it for the carbon and hydrogen first. If we are talking about carbon and hydrogen, so carbon and hydrogen upon combustion they produce this kind of reaction. Always remember the number of carbon atoms present in the hydrocarbon will give you that moles of carbon dioxide, and half of the moles of water are produced as many number of hydrogen are present in the original compound or the hydrocarbon. So let us start this reaction. So we are conducting this reaction. This reaction is called as the combustion reaction, and the product of combustion are now passed through the U-tube, which is a new tube and containing two things. What two things are there? There we are combusting it, which is very easy to understand. See, this is pure oxygen which we are providing. Excess of oxygen is there so that we can have the proper products produced. So now after passing through CuO pellets, after passing this through CuO pellet, it will produce two things. One of them is called as CO2. So anhydrous CaCl2 does what? Absorbs water. Anhydrous CaCl2 does what? Absorbs H2O. And KOH solution, being basic in nature, it also absorbs acidic gas. So absorbs what? Carbon dioxide. So carbon dioxide will be absorbed here, and some mass of this tube will be increased, and that will be measured. This also will provide you the mass of water. If you are knowing the mass of water and CO2, then what you can do is, see, if you know that W gram of CO2 is gained, so guys, you can find out the number of moles of CO2 by WCO2 upon molar mass of CO2 is 44 gram per mole. So now if moles are given, this will be also equal to the number of moles of carbon. As I told you, the number of moles of carbon are equal to the number of moles of CO2. So mass of carbon will be how much? Mass of CO2 that we got in that tube divided by 44 into molar mass of carbon is 12. This is the mass of carbon you are getting. So that's it, it's that gram. Now another thing could be talking about water. So let us suppose mass of water is known to us because that is the mass of that U-shaped tube that was increased. So we can find out the number of moles of H2O by predicting the number of moles of H2O upon its molar mass is 18 gram per mole. So we know that how many number of water molecules are there, since one water molecule contains 2 moles of hydrogen, so we have 2 times of number of water molecules is equals to the number of moles of hydrogen. So mass of hydrogen will be how much? 2 times the number of moles of hydrogen, and the molar mass is simply 1 only. So that's how we do. So 2 multiplied by the mass of H2O we received upon 18 is equals to W of H2O by 9. So once you are known with this, see, you can check it out over here. Exactly the same thing which you are doing. So by multiplying it by 100 by m, what is 100? Percentage. M is the mass of the organic compound. 100 by m, if by multiplying it by 100 by m, you will get the answer, the percentage composition. So about the one which we have studied right now, this is the quantitative analysis which we are doing. Now let us just find out the percentage composition of this compound. On the complete combustion, 0.246 gram of an organic compound gave 0.198 gram of carbon dioxide and 0.104 gram of water. Determine the percentage compositions of the carbon in the compound. Okay. So now see everyone, Percentage carbon. So first you got to know about the number of moles of CO2. Mass of CO2 which we are getting is how much? 0.198 divided by 44 gram per mole. This is the number of moles of CO2. Now if you multiply this number, that is also equals to the number of moles of carbon, because one CO2 contains one carbon atom. Then mass of carbon atom will become up as 1.198, 0.198 multiplied by upon 44 into 12, this much gram. So now simply do one thing, and percentage carbon can be calculated as how much is the substance is given, 0.246. So do one thing, 0.198 upon 44 upon 0.246 into 12 into 100. This is your percentage of carbon. Now please check it out, how much does it come. You may use some approximations if needed, but please try to find out the correct answer from here. I think A is the correct answer. That will be nearly by come up as 21.95%. Hopefully this part is absolutely clear to all of you, and if not, please do it by your own, because the concept behind it is already explained and I am not receiving any kind of doubt from you. So it's pretty much clear that you might be getting the concept. Now application part is all yours. You better try some questions and you will get comfortable in it. Next we have detection of nitrogen. Nitrogen detection requires two, not detection. We are actually quantitatively finding out the amount of nitrogen present inside the compound. So for this we have two important methods. One of them is called as the Dumas method, another one is called as Zildal's method. So what these methods are, let me explain to you. So we are supposed to react the organic compound with CuO, and it produces some set of nitrogen. So I'll explain it very simple. This is very simple. Dumas method, what we do, we are supposed to make our given organic compound react with copper oxide, cupric oxide, which produces as many as number of CO2, half of the water, and exactly the same amount of nitrogen, which is Nz. So we will get Z by 2 N2. Total number of atoms are the same only. Now out of this nitrogen, what we can do is we have to first of all take the current condition to STP. So how can we lead it to the STP? So let the mass of an organic compound be m gram. Volume of the nitrogen collected is V1 ml. So what we have got here from here, we have got the volume of nitrogen gas. So how did we get it? Anyways, let me read it. The traces of nitrogen oxides are also formed if any are reduced. Traces of nitrogen oxides formed if any are reduced to nitrogen by passing the gaseous mixture over heated copper gauze. The mixture of gases so produced is collected over the aqueous solution of a potassium hydroxide, which absorbs the carbon dioxide. Nitrogen is collected in the upper part of the graduated tube. So guys, what is happening? What conditions are we right now maintaining on which we can find out the existing volume? So let us say that volume right now is V1 ml and the current temperature of room is T1 temperature. Then what will be the volume of nitrogen at STP? What will be the volume of nitrogen at STP? So this will be P1 V1 into 273 by, I don't know what is it doing. Okay, I think I can explain this part. V is different, pressure is also different. And we are bringing it to, okay. Anyways, so guys, we initially we got the volume of nitrogen, and this is actually known to us. This is known to us. We have T1 temperature also known to us, P1 pressure also known to us. Everything is known to us. So using assuming it at ideal gas, number of moles of nitrogen can be calculated by PV by RT. So this is how you can find out the number of moles of nitrogen. Why are we converting into that, yaar? Why are they converting into normal temperature STP? Because at STP temperature will be known, pressure will be known, and we can find out the volume. So we can directly apply this formula. Okay, got it. Okay, got it. So there are two procedures. One of them could be this. So this is one part, or we can do what? Convert it to, or we can convert volume of N2 at STP, standard temperature and pressure. So what happens at STP? Everyone, please mind this. This step is very important step. We know that number of moles are the same only, PV by RT. So same, we know the pressure P2. P2 is equals to, I guess, 1 atm or 1 bar at STP. We know V2 has to be found out. Temperature T2 is also known to us. How much is T2? How much is T2? Okay, tell me. T2 temperature will be the room temperature, that is, let us suppose we are taking it as 0 degrees Celsius, as 273.15 Kelvin. Volume, we don't know. Number of moles of nitrogen will be the same only. The same. So apply that formula. So using this formula, PV by RT is equals to P1 V1 by RT1 is equals to P2 V2 by RT2. We can find out the value of V2. So V2 will be how much? V2 will be V1 T2 by T1 P2. This is how we can find out the volume of nitrogen gas at STP. This is the volume at the rate STP, standard temperature and pressure. Once the volume is known to you, you can apply the formula that number of moles of nitrogen gas will be equals to how much? Number of moles of nitrogen gas at STP is how much? Volume at STP upon 22.4 liter per mole, if you are taking this volume in liter. So once the moles are known to us, we know the number of moles of nitrogen atoms, 2 times of volume upon 22.4. If you know this, then mass of nitrogen can be detected as 2 into 10 to the power 2 into volume in liter upon 22.4 into 14 gram. So mass of nitrogen can be detected like this. Okay, let me take you to one question first, then we'll understand. So why are we converting into the another condition? That is still mystery to me. We had temperature, we had pressure. Anyways, both of the ways can be applied, not a problem. Both of the ways can be applied. Let us try solving one question first. In Dumas method for the estimation of nitrogen, we had 0.3 gram of an organic compound which gave 50 milliliter of nitrogen and collected 3 Kelvin, collected at 300 Kelvin and 715 mm pressure. So calculate the percentage composition of nitrogen. So guys, I can do it directly also. How? So I'll simply find the number of moles of nitrogen first, and I'll multiply it by 28. That will be the mass of nitrogen, and that is the mass of nitrogen present everywhere. This is what the principle of atom conservation says. So number of moles of nitrogen will be how much? PV upon nRT. So maybe we were trying to ignore R by that time, or what were we doing? And we also have aqueous tension 15 mm Hg. So now this question has become very easy, everyone. Do you know what is the pressure of moist air? Moist gas means it is mixed with some water vapors. This is actually equals to pressure of gas plus pressure of water. So water is already given us that 15 mm Hg. This is given us as 715. The remaining will be 700 mm Hg. Okay, so we have got one thing now. We have got one thing. So now we can apply the formula of number of moles, I guess so. But if you don't want to use the value of R, then only the problem, then you need to convert it to STP. Otherwise, we can directly do it. No need to consider anything here. We can directly do it. See, I'll do it. Check it out. I'll do it. So we'll apply PV equals to nRT and finding the number of moles of N2. So how many moles are there? PV by RT. Pressure is already given to us, 700. Volume is already known to us. How much volume it was collected? 50 ml. So 50 ml is 15 to 10 to the power minus 3 I'm writing, and 700 upon 760. So this is right now in ATM, and this part is right now in 15 to 10 to the power minus 3. This is in liter. So if in ATM and liter upon R you need to take 1 by 12, because whenever ATM and liter units are taken, then R is 0.0821 liter atmosphere mole inverse Kelvin inverse, 1 by 12. Temperature is 300. Please solve this part and let us get to the final answer. What if we can get? So this will become 6. This will become 2. Will go up 1400 upon 760 into 10 to the power minus 3. These are the number of moles of nitrogen. So mass of nitrogen will be what? 1400 into 760 into 10 to the power minus 3 into 28 grams. So if I need to calculate out the percentage nitrogen will be how much? The mass of nitrogen. So let us solve it. 1.4 into 28 divided by 760. And upon mass given is 0.3 into 100. This is the percentage. Can you please help me to find the value? Let me try using my phone. What value do I get? Just to get the idea. I'm getting 17.19 here. So somewhere we are into 17.2%. Can we get the answer? Okay, this is also the same. So we are getting the same answer that we expected. And why are we getting a bit different answer? Not exactly the same, because I considered R as 1 by 12. Actually it is 0.0821, but both of them are fine. Both works. The answer are quite different to each other. We can find out the value like this. Hopefully this part is absolutely clear to all of you who are watching here. Next comes the Zeldal's method. What does Zeldal's method say? This method says that the compound containing nitrogen is first heated with the concentrated sulfuric acid. Then whole the nitrogen gets converted into ammonium sulfate. That solution is now treated with the excess of sodium hydroxide, where it is converted back into ammonia gas. So blah 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 is done, everyone, but it's very easy. See, if you already know what is the amount of ammonia, so what do we do? Ammonia produced and determined by the amount of sulfuric acid consumed in the reaction. The amount of ammonia produced is determined by estimating the amount of sulfuric acid consumed in the reaction, and the leftover will be the one which is left even after reacting with sulfuric acid. Okay. So anyways, I'll take you directly to a question and then I'll explain how does it work. Till here it is pretty much simple, that organic compound is given to you. You need to react it with sulfuric acid, it will convert it into ammonium sulfate. On reaction with alkali, it will give you ammonia gas. So now this ammonia gas will be treated with sulfuric acid like this, and some of the ammonia gas will be in excess. So that excess part, sorry, we have H2SO4 in excess here. So the excess of H2SO4 is reacted with volume of NaOH. Not getting it. Anyways, we'll come to a question first and then we'll understand. During the estimation of nitrogen present in an organic compound by Zeldal's method, the ammonia evolved from 0.5 gram of the compound. In Zeldal method of estimation of nitrogen, is neutralized by this. So guys, what is the need of doing so many calculations? Yeah, it's simply the concept of redox reaction, है ना? Gram equivalents need to be equate. N1 V1 equals to N2 V2. So do this. Surgi, gram equivalent of NH3 is equals to gram equivalents of H2SO4. How many gram equivalents of NH3? Number of moles of NH3 multiplied by N factor is always 1 for ammonia. Ammonium hydroxide is also has the basicity of 1, acidity of 1. So 1 is the N factor. Coming to H2SO4, what we are given up with? Neutralize again this. So during estimation, okay, this is done. Then we have the ammonia evolved in 0.4 gram, count on this. Neutralize 10 ml. So this is neutralizing what? 10 ml into 10 to the power minus 3 in order to find out the number of moles. Into molarity is 1 molar, into N factor is 2. N factor also need to be taken for H2SO4. Gram equivalents are needed to be equated. So number of moles of ammonia comes how much? 2 into 10 to the power minus 2 moles. So guys, mass of, so how many number of moles of ammonia are here? That will also be equals to the number of moles of nitrogen, and that is equals to 2 into 10 to the power minus 3 moles. 3 or 2? No, 2. 2 to the power minus 2 moles. So find out the mass of nitrogen will be how much? 2 into 14 into 10 to the power minus 2. 14 is the molar mass of nitrogen. Simple N. So this will become 28 into 10 to the power minus 2 grams. So percentage nitrogen is how much? How many grams of nitrogen is this? 0.5. So just simply say 28 by 0.5 into 10 to the power minus 2 into 100. So how much is this value? Double the 28, it will become 56%. This is my answer I got. So guys, you don't even require to rote learn the everything. We know the procedure that the compound will be treated with sulfuric acid, where nitrogen will be converted into ammonium sulfate, and then ammonium sulfate with NaOH gives you ammonia gas. So whatever the ammonia gas is released there, that will help you to find out the number of moles of nitrogen. So many titrations are given over there. Just go through that titration and try to find out the value of mass of value of the number of moles of ammonia. Once these are known, you can easily find out the mass of nitrogen present in it. See, it's very good. Try this question. Where we cannot apply Zeldal's method, Zildal method cannot be applied to detect the nitro compounds. In nitro compound we can find, because all the other compounds will be providing you ammonium sulfate on reaction with H2SO4, but nitro compounds will not provide you. This NO2 compounds will not provide you. Wasn't it mentioned anywhere? See, this is here, star marking it. Not applied to the compound which are containing nitrogen in nitroazo group, nitrogen present in ring such as pyridine. Nitrogen of these compounds do not change to ammonium sulfate, and I told you the way. Why don't we apply this? Then guys, we have halogens. For halogens, the detection of measurement of the amount of halogen present, percentage of the quantity present of halogen. We have this method called as Carius method. So what is Carius method? Believe me, this is very simple and won't take too much of your time. You can read this thing in this, that there is a Carius tube, or we call it a furnace. A known mass of an organic compound is heated with the fuming nitric acid, hot nitric acid, where it in the presence of silver nitrate. So what has happened? If any impurity is there, that will be oxidized, and further things like all the halide ions, apart from this, halide ion will be X minus is allowed to react with the silver nitrate, that will produce AgX, and you know the mass of AgX produced. Mass is calculated, how much of PPT are you getting. So let us suppose you know the mass of AgX, and let us say the mass of AgX is how much? M1 gram, and originally the organic compound So guys, nitric acid is helping us to make, what does it make? Yeah. Maybe the individual ions it will provide you. So this basically decomposes the organic matter. So anyways, this reaction will directly go, and whatever the number of carbon and hydrogen there, they will be converted down into their oxides, CO2 and H2O, and this halogen will be converted into AgNO3. So this AgNO3, the mass will be known. Let us say this is M1. The original mass of this organic compound, let us say it is m gram. So this number of moles can be identified of halogen. How would it come? It will also be equals to number of moles of AgX, isn't it? So just simply do one thing, m1 gram divided by the molar mass of AgX upon and multiplied by whatever the molar mass of halogen is there. This is also equals to the number of moles of this halogen into molar mass of halogen divided by small m, which is the mass of organic compound, into 100. This is actually the percentage halogen you are getting. That's how we get the percentage halogen. So let me take you to one example, one question, and that will basically clear out everything. In Carius method, in the estimation of halogen, 0.15 gram of organic compound gave you 0.12 gram of AgBr. So guys, we know that the number of moles of Br will also be equals to the number of moles of AgBr, applying the law of principal of atom conservation, PUAC. So this will become how much? 1.02 upon. So what is the mass of this? Silver has mass of 108 and bromine has a mass of how much? 80. So 188 gram per mole is the molar mass. So 0.18 upon 188 moles. So mass of bromine will be how much? 0.12 upon 188 into 80. So this is how much gram of bromine is here. Percentage bromine you want to find out. Do the calculation. 0.12 upon 188 into 80 divided by 0.15 into 100. Now solve this thing and you'll get your answer. 15 and 12 can be 15 and 4. Then this is 47. This is 8000 by 235. If it would have 200, then the answer would have come 240%. So it is slightly lesser than 40, 34%. 34% is the correct answer. Mathematics or calculation should be stronger. If you know the mathematical calculations well, then there is nothing which can stop you. And look at these examples, they are highly easy equations I found. So only the procedure must be known and then you are pretty much able to do whatever you want. So guys, next we have sulfur. So we don't need to do so many things right now. What initially we are doing is just try to find out that initially we are reacting with sodium peroxide. So sulfur is oxidized to sulfuric acid, H2SO4. So now what we are doing is that we are organic compound. We have this organic compound. And this organic compound contains sulfur, which is now reacted with concentrated HNO3, which is an oxidizing agent, and it forms H2SO4. This is reacted with barium chloride. It converts it to BaSO4 PPT. And if you know the mass, let's say M1 gram, and the organic compound be m gram, so you can find out the number of moles of sulfur, BaSO4. Number of moles of BaSO4 is equals to number of moles of sulfur. This is called the principle of atom conservation. Number of atoms are always conserved. Number of moles of the atoms are always conserved. So BaSO4 has given you sulfur. So percentage sulfur will be how much? You can find out the mass. W of sulfur is equals to number of moles M1 divided by molar mass of barium sulfate into molar mass of just sulfur, which is 32. So percentage sulfur will be 32 into M1 upon barium sulfate is a molar mass of 233 upon the mass of organic compound given and multiply by 100. That's how you get the percentage. Everywhere we are using the same basic concept of mathematics here. It's more or less now like mole concept rather than strictly some organic chemistry. Try this question now. Try this question. Okay, in sulfur estimation, 0.157 gram of an organic compound gave 0.4813 gram of barium sulfate. And what is the percentage of sulfur in this compound? So guys, it's easy that we can do a number of moles of barium sulfate, which is also equals to the number of moles of sulfur, will be equals to 0.4813 divided by the molar mass of barium sulfate. Now tell me the molar mass of barium sulfate. How much is the molar mass of barium sulfate? 233. That 233, sure, no, barium sulfate, yeah, might be. then that multiplied by, okay, this is the molar mass, this is the number of moles. So percentage sulfur will be 0.4813 divided by 233 multiplied by molar mass of sulfur is 32 divided by mass is given is 0.157 into 100. Now please try solving this equation and you will get your answer. If you are pretty much able to solve your equation, you will get your answer. This is how we do it. A very easy one. I personally liked it very much. Let's see, 42. Right, 42%. Now last we have, at finally we have phosphorus remaining, and rest is already covered by us. So we'll complete this also, and then the another part will also be covered. But until then, we should finish this part first. We'll take a lunch break for a while. We'll join back, and then we'll finish the remaining part. Okay, phosphorus, what do we have? We all know that in the reaction we were we were initially oxidizing the entire organic molecule with Na2O2 or concentrated HNO3, which converted the entire phosphorus into HNO3, H3PO4, phosphate. That later on reaction with, let's say, NaOH or sodium salt will give you sodium phosphate. But ammonium phosphate we produced. How? On reaction with okay, remember it, ammonium hydroxide and ammonium chloride and molybdenum oxide, I remember. So this gave you ammonium phosphomolybdate. So we must know that the molar mass of ammonium phosphomolybdate is this much, because we can understand and we can find out the mass of ammonium phosphomolybdate formed. So if you know this, number of phosphorus moles will be equals to the same only, number of moles of phosphorus will be equals to the number of moles of ammonium phosphate molybdate. Number of moles are equal. So now you can find out what? Mass. So which is equals to the mass, let's say M1 is here and their molar mass is 1877. So either it will be given in the exam or you can find it out. 1877 number of moles are here. So mass of phosphorus will become how much? The number of moles of phosphorus, which is M1 divided by 1877 and multiplied by the molar mass of phosphorus, which is 31. So once you know the mass of phosphorus, find out the percentage phosphorus in organic compound. So M1 into 31 divided by 1877 into small m multiplied by 100. That's how you get your percentage phosphorus. So guys, we are not supposed to take too many things in our mind, because see, this is an easy part, this is an easy chapter. If we pick so many things, no, that it will complicate our basically procedure. So just simply approach them and find out whatever it is needed. So rest is hydrogen, last is oxygen. So guys, wherever an oxygen atom is required to find out, first you do calculate all and then minus them with 100. See, there is no direct method of calculation of oxygen. So do one thing, usually you find all carbon, hydrogen, oxygen, nitrogen, whatever it is, and then at last oxygen will be calculated by 100 minus the given percentages. Or there is one more thing that we can do, we'll try to make a complex from where? Here. Compound is first heated and some products will be gained like oxygen. So okay, a definite mass of organic compound is decomposed by heating in the stream of nitrogen gas. Means we are taking inert atmosphere, we are not bringing any oxygen, we are simply breaking this compound out. The mixture of gaseous product is produced, which when passed through red hot coke produces the oxygen. Oxygen is converted into carbon monoxide like this. See, compound is there, this is produced by CO. So now when carbon monoxide is, this mixture is now passed through warm iodine, where I2O5 is produced when carbon monoxide is oxidized to carbon dioxide, producing iodine. So what we are doing is we are reacting this carbon monoxide with I2O5, iodine pentoxide, and it produces simply iodine and CO2. So there are so many things he is doing here. Tell me the correct. What should I do? Okay, now we got it. So at last we'll know that what is the mass of carbon dioxide. Let's say mass of carbon dioxide is M1. So M1 mass is of the carbon dioxide divided by 44. Carbon dioxide will be divided by 44, and 44 is actually the mass of okay, let me give you an idea here. So now ultimately you will come to know about the mass of CO2 produced. Let us say this is M1 gram. Our organic compound originally, which was containing the oxygen atoms, has a mass of small m gram. Now we all know that number of moles of oxygen is equals to 2 times the number of moles of CO2, because a CO2 is formed from 2 moles of oxygen. So what I'll do, I'll simply find out the number of moles of CO2. So M1 divided by 44. M1 divided by 44 is the number of moles of CO2. So number of moles of oxygen will be how many? Into 2. This is the number of moles of oxygen. So mass of oxygen 2 into 16 into M1 upon 44. This much amount of oxygen we are getting. So thus percentage oxygen is how much? The mass of oxygen, which is 32 into M1 upon 44 into 100 upon cap small m. So be percentage of it. I'm not getting why is 44 I'm using and he is using 88. What is wrong? So on making the amount of CO produced in equation 1, equal amount of CO is used. Thus 88 gram of carbon dioxide is obtained if 32 gram of oxygen is liberated. Okay, oxygen gas is liberated. Now yeah, I don't know, man. Why is it coming a bit different? 88 gram of CO2 is obtained. Okay. I got the answer now. Guys, see what is happening. Some of the molecules of oxygen are coming from iodine also. Warm iodine pentoxide was given to us. 5 was already there. Then 5 were used for CO. So half of the moles are only for CO2. I got it now. So whatever the number of moles of CO2 we are getting, let us suppose CO2 which we are getting, number of moles of number of moles of oxygen. So only half are coming from organic compound, and half of them are coming from iodine pentoxide. Half are coming from I2O5. So that is why half we have to consider. So just take this thing as number of moles of oxygen from organic compound. OC will be whole divided by 2, like that. So now it will be 2. So either you can write it 16 m1 by 44, or you can make it. Now we are getting the exactly same 16 by 44 or 32 by 88 is the same, only multiplied 2 by both sides. So that is how we do. And now we'll take a break from here, a lunch break, then we'll rejoin and we'll rejoice the lecture. We have a lunch break here. Wait for just 15 minutes and we'll come back. Okay. So those who haven't liked the session now, like the session ASAP. So hi guys, I'm back, and we had some issues here related to this. Actually, the screen got off meanwhile, and we are just resolving the issue only. Yeah, hi Kushagra. Yeah. So let me take you directly if possible. Yeah, entire notes will get off. So guys, we already have covered the major part of today's lecture. That was initially I taught you some of the methods of. Uh, no problem, I'll upload it. So we have already covered this part, methods of purification. We covered qualitative analysis, like how can we detect the presence of some element in the organic compound, and then we finished the quantitative analysis. These two parts are left right now. I would take another 1 hour and then we'll finish this remaining part of this chapter. So there we go. There we go. So this is our title, everyone. Determination of empirical formula. Hopefully, I'm pretty much audible to every one of you. And even if not, let me just wear the mic. Okay. What is our today's topic and onwards topic? Calculation of the determination of the empirical formula and molecular formula. So guys, before starting, let me give you one example on such. So how to determine the molecular formula and empirical formula. This belongs to our mole concept only. If you have already gone through mole concept, then you already remember and know the concept behind this. We have molecular formula. So molecular formula is the exact chemical composition that is present inside a molecule. So basically, let me just directly write an example. Let's say benzene is our example. Benzene. So benzene has a molecular formula of C6H6. So empirical formula, what is the meaning of empirical formula? So empirical formula is actually the smallest possible whole number ratio for the elements present in a compound. So this will become CH, C1H1. Now let's see if the same thing I tried for ethene or ethyne. So ethyne has a molecular formula C2H2 and empirical formula will be C1H1. So guys, you would observe one thing here. What is the observation here? That every time you multiply the empirical formula by some number, this gets back converted into molecular formula, isn't it? Try this. So if we multiply the empirical formula by some number, it gets converted into molecular formula. That's what I'm saying. So now let's do one thing. So guys, not just the mass, even with the formula, we have two simple formulas to remember. Number one is, if you want to calculate out the molecular formula, it is equals to some number, which is no doubt, it's a positive integer and multiplied by empirical formula. Similarly, if I want to calculate the molecular mass of a compound, that will also be equal to, molecular mass can also be written down as the same positive integer, not the number of moles, into empirical mass or empirical formula mass. So do remember these formula. These are from the mole concepts only, and these are pretty much helpful in calculation of the molecular formula or determination of molecular formula of organic compound. So let us just take one example, everyone. So I'm giving you one example. So let's suppose in a question, sometimes the question is given like this, that there are two elements which is a hydrocarbon is made up of, and so hydrogen here is 12% by mass and carbon is 12 yaar. Okay, this is 20% by mass, this is 80% by mass, right? This is given us by mass. This is your percentage composition. Let us suppose this is given to us. So we have to assume them in the terms of grams only. Let's say 100 gram is the total sample of this compound, of this hydrocarbon, and 80 gram and 20 gram are the given mass of these, right? First I'll calculate the empirical formula. Also we are given with molecular or molar mass of the compound, molar mass of hydrocarbon is equals to, it is given to us 30 gram per mole. Molar mass is represented as 30 gram per mole. Molecular mass is written sometimes in the terms of U, 30 U. So now out of these information we got to predict, we got to find out the formula, molecular formula of the compound. So how can we do it? First of all, the first thing is to calculate out the number of moles. How many number of moles are there? Given mass upon molar mass. Given mass upon molar mass. So guys, take their ratio. Take their simplest ratio. And that should be whole number also. So 20, you can cut it out. This is 4 by 12 ratio 1, or this is 1 by 3 ratio 1. Multiplied both sides, it will become 1 ratio 3. More or less, this will become 1 ratio 3. So this 1 ratio 3 gives you the empirical formula of this compound as, empirical formula will become 1 carbon 3 hydrogen CH3. Very simple. Now another question comes is, are we given with the molecular mass? Yes, which is 30. And we can also find out the empirical formula mass. So empirical mass will be empirical mass, which is the mass of the getting from the molecular empirical formula only. 1 carbon is 12, 3 hydrogen is 1, it is 15. So I told you this formula of calculation of N. N is nothing but the molecular mass upon empirical formula mass. So guys, unit you should take as 30U here, and it will become 15U. So just simply 30U, 15U, it will become 2. So if N is 2, you can directly multiply it with the empirical formula, and then you get the molecular formula. How much? CH3 multiplied by 2, C2H6. Now you solve some questions based on the same concept and try to gain the confidence which we are right now getting. There we go with the first question, everyone. Please try this question by your own. We have this question of the molecular formula of a compound is 78 and its percentage composition is 92.4% and 7.6% respectively. So determine the molecular formula of this compound. So guys, it's a very simple question. Just simply write carbon and hydrogen. Whatever the elements is there, just write it. We have 78 molecular mass. We have percentage composition 92.4. Simply write 92.4 gram. We have 7.6 gram. We got to divide by their molar mass to find out the number of moles. How much is it? This is 7.84. 7.7 it is coming, and this is also 7.7. So I got 1:1, nearly 1:1, isn't it? It is 7.6, nearly. This is 1:1. So simply we got the empirical formula. The empirical formula will be CH, and empirical mass will be, and what will be the empirical mass? How much is the empirical mass? We have carbon 1 and 1, 12 plus 1, 13. 13U. So what I can get? Value of N, 78 by 13, 6. So simply find out the formula. C6, it's benzene we are talking about. A. So using this formula, we can find out the molecular formula of a compound if we are known with the percentage composition. That also we have discussed till now. In our previous section, we were discussing about their percentage composition only. Quantitative analysis of the organic compounds we were discussing. We have one more question, a similar question, and let us try this question also. So determine the empirical formula and molecular formula of these. A molecule with molecular mass of 180 gram per mole, so you can take its molecular mass as 180 U. This is called as the molar mass given to us. Analyzed and found that some 40% of carbon something is given. Simply write carbon, hydrogen, oxygen. So how much is carbon here? Carbon we have 40%, 40. Hydrogen we have 6.72 and oxygen we have 53.28, and simply consider them in the gram only. Let us say this is the mass given to us. So number of moles will be how much? 40 by 12, 6.72 by 1, and 53.28 divided by 16 is the mass of one oxygen atom. Try finding out the nearest possible ratio. This will be 3.33. Same 3.33. This is 6.72, and this will be 3.33. So guys, this will be 1:2:1 is coming, which is a nearly whole number ratio, 1:2:1. So using this formula, you will get the empirical formula. You can get what? Empirical formula. So what is the empirical formula? C1H2O1, and its empirical mass will be carbon 12, hydrogen 2, 16 is the oxygen, 30 we are getting 30U. So using this data, you can find out the value of N, which is molecular mass upon empirical mass 6. So the formula will become C6H12O6. This is your molecular formula. And believe me, so many questions have been asked previously upon this concept. And it's an important concept that I introduced here, determination of empirical and molecular. Let us check the correct answer. Yes, B, C6H12O6 is the perfect answer. So there we end with this topic, and now we have the final topic of the day, final topic of this class, detection of the organic groups. So there are some important chemical groups we have. Organic compounds have some functional groups in them, like alcoholic group, ketonic group, aldehydic group. We are supposed to learn all of them. How are they represented? How are these values find out? How to find out this value? So let me start it from here. Detection of organic groups. How are you going to detect which organic group is present where? So number one is hydroxyl group or alcohol or phenol. So guys, we all know this is called as alcohol. This with benzene ring is called as phenol. So hydroxy group we have to check out. Number one test is called as Lucas reagent test. So Lucas test is conducted for 1 degree, 2 degree and 3 degree. So it's very simple test, everyone. ROH in the presence of what we are using, HCl, and ZnCl2 anhydrous produces RCl plus whatever the compound is there, water. So this reaction, this RCl and ROH, the difference is, this is, alcohols are generally transparent. Alcohols are generally what? Transparent. But alkyl halides are cloudy, turbid or cloudy. So what we need is, this reaction follows SN1 mechanism. This is a simple substitution reaction, nucleophilic substitution reaction, and it follows SN1 mechanism. We all know the rate of SN1 reaction. So rate of reaction is 3 degree, 2 degree, 1 degree. So guys, this happens that 3 degree alcohol gives instantaneous turbidity. This gives after 5 minutes, and then we have 1 degree, doesn't give, or a long time. Check it out. So this is how we can find out alcoholic group, which alcoholic group is there, 1 degree, 2 degree, 3 degree. We can detect the group. Next is Victor-Meyer test. Again, this is conducted for the Victor-Meyer test is conducted for whom? For the alcohols only. So guys, primary alcohol Victor-Meyer test gives immediate, not immediately, yeah, this is something else. H1O, okay. So guys, this is how this reaction works. Let me tell you. Victor-Meyer test. Let us suppose we are given with a, this is called as primary alcohol. So primary alcohol, this is called as 1 degree alcohol, is reacted with phosphorus oblique I2 or HI to give you alkyl iodide, RCH2I, right? To give you RCH2I, which later on is reacted with AgNO2, silver nitrite, to give RCH2 CH2NO2. If you carry out the same reaction with potassium, KNO2, then it will give you ONO. But we are not supposed to make ONO, we are supposed to make NO2. If we react this with HNO2, which is nitrous acid, it's a kind of source of N double bond O group. So this will add one hydrogen will be removed and one N double bond O group will be reflected here, NO2. And this is actually red in color, not red, this is blue in color. Or blue or red, yeah. Blood red color it will give. This is blue in color. And when it is treated with NaOH, basic medium, one of the hydrogen will be removed. So it is dissolved. So this is a salt which deep red color. So this is what it follows for 1 degree. So let us come to the secondary. What happens in the case of secondary? Secondary doesn't have any acidic hydrogen after this reaction. So like after this reaction, what does it form? This is where it is. So this doesn't have any acidic hydrogen. With NaOH it gives no reaction. No reaction. And that is why blue color retains. And finally, 3 degree tertiary does not react with HNO, no reaction, and that is why colorless. So this is called as the Victor-Meyer test. Then we have iodoform test. Iodoform test. I didn't have any space. I'll explain iodoform test here. So guys, iodoform test is something which is not given by every single alcohol. Only those alcohol will give you this test which are connected to this methyl group or any compound which contains this methyl keto group. They only give the test. Compounds with group. Which group? This group only give this test. So what happens in this test? Consider a chemical reaction. So in this reaction, let us suppose this is CH3, C double bond, or let us say COH, and we have CH3 also. We are supposed to get it reacted with I2 plus NaOH. This is the reagent that we use. It gets converted into CH3, C double bond O, OH plus CHI3. This is your yellow PPT called as iodoform. This is your iodoform. All clear, everyone? Only those alcohol will give this test which are no doubt secondary and with this group. Secondary or tertiary, but with this group. That is more importantly this group. Next test is for phenol. Phenol detection. Earlier we were doing alcohol detection. Now we will do phenol. Bromine water test we do. Bromine water. If you react with bromine water, so water being highly polar and phenol being highly activated ring, easily accepts the electrophile and Br positive as an electrophile attack on all three sites, all three electron rich site, ortho and para. And this kind of compound is formed, which is a yellow color PPT. Let me check what color is it. If you add this drop by drop, it will give you a white PPT, sorry, it will give you a white color PPT called as bromophenol. No yaar, wait yaar, dissolve in so white only, white color PPT will be formed. This is that. Another test is ferric chloride test. So ferric chloride test is what? We have it is conducted in HCA in the presence of acidic medium, and not acidic, we also call it neutral ferric chloride test somewhere. So let me check what reaction happens here. Yes, so it will create acidic medium because it the byproduct is HCl. So guys, let's take this reaction very simply, that let's say this is phenol and we are reacting with FeCl3. So this kind of complex, does it make Fe, OPH, FeOPH, whole thrice, and this is actually purple in color, plus 3 HCl will be formed. This is how this reaction goes. So this reaction is only occurred with this. If the same reaction happens with ROH and FeCl3, no color is observed. So negative test. Correct? Next we have aldehyde. Please read it out, everyone. It's pretty much clear, written everywhere. Just read it out. Allow me a moment. I'll be back and we'll join you soon. Yeah. So hopefully you all have read it, and I'll explain this part to you, and then we'll move forward to another functional group. Alcohol and phenol we already have discriminated. So alcohols can be distinguished 1 degree, 2 degree, and 3 degree by Lucas test and Victor Meyer test. Then we have phenol, neutral FeCl3 test is given by phenol, and bromine water test they give. We have another functional group, carbonyl group, which is aldehyde. So aldehydes are detected by Felling's test and Tollens test. Actually, Tollens test is done for both aliphatic and aromatic aldehyde because Tollens reagent is a relatively stronger oxidizing agent. Felling solution is only for, only aliphatic aldehyde give this test. Aromatic aldehyde do not give test, but this except alpha hydroxy ketone also give this test, but other ketones do not, and hemiacetals and formic acid also give this test, but do not give the acetals. And always remember that both aliphatic and aromatic aldehyde give this test, give Tollens test, while Felling's test is given only by aliphatic aldehydes. Okay, just learn it, guys, and remember it. Let me check one important information. Okay, so I was just checking this out, this information, that which alpha hydroxy ketone will give this test, because all cannot give. That was I was just confirming. All cannot give. Only alpha hydroxy ketone with which are present at the terminal. Present at the terminal. Anyways, I can give this example. We can pick this example, everyone. Let us see. So, if carboxylic acid is there or not carboxylic, first of all, alpha hydroxy. So, this is your alpha hydroxy group and HH. Then it is a ketone. So, guys, this should be like this alcohol or this hydroxy group should be terminal only. So, we know about tautomerism. You might have heard tautomerism goes here. Let me check क्या था वो. So this type of compound can give you the okay, I'll come SP, I got your message. I'll come up with such strategy. I'll come up with some strategy. Check it out, everyone. We know that one of the tautomeric form will be like this. Alpha hydrogen is this. It goes like this. One of the tautomeric form will be this. So how does it look like? OH and then CH3. This is one of the tautomeric form. Another tautomeric form could be using this hydrogen. Using this hydrogen, right? This will become C minus somewhere, and this will accept the electron pair. So it will become somewhat like this. CHC double bond O. Now it has become aldehyde. Sorry. Now this is an aldehyde. So we started it with alpha hydroxy ketone, which automatically transformed itself into aldehyde. That is why they give tolerance test, right? This gives the tolerance test. Write it down, everyone. Then there are also some more compound which are having acidic hydrogen, and somewhere they form the Similarly, HCOH also gives this test, formaldehyde. Formaldehyde under the influence of ammonical silver nitrate. I'll conduct one basically a lecture later on about all the tests, because right now I haven't taught you about the complete 12th standard chemistry. So there are some, like not some, majority of the concepts they arrive from the 12th class chemistry only. You might be familiar with the Lucas test, because that comes with SN1 reaction. Other reactions we haven't taught you, that is why as of now it is difficult. Later on we'll manage it, later on we can do it. So this is working as a silver will be deposited down, and this HCO will be oxidized to CO2. Like this is how the reaction goes on. Anything else is there? Hemiacetals will be converted into hemiacetal can be converted into ketone, aldehydes, and that is why they give this test. Acetals do not. Anyways, let me lead you. Next is we have test for carboxylic acid. So aldehyde ketone, after aldehyde ketone we have carboxylic acid test. So carboxylic acid test is very simple. The test with dilute or 5% sodium bicarbonate. We call it sodium bicarbonate test. So guys, this has been said that any acid which is stronger than phenol will give this test, or sometimes we say any acid which is stronger than, this is NaCO3. Carbonic acid is H2CO3 will give this test. So sodium hydrogen carbonate on reaction with this, as a base it reacts and it converts CO2 into CO2Na, a salt, plus CO2 plus water. Then we have, and this CO2 is actually bubbled through water. It produces the brisk effervescence of CO2 gas. Then we have alcohol, phenol and carboxylic acid distinction test. How can we discriminate between these three functional groups? So all the alcohols react with sodium metal to evolve hydrogen. All phenols react with sodium metal and NaOH but do not react with NaCO3, and all carboxylic acid react with sodium, NaOH and NaCO3. This is a very good common relationship between all of them, that carboxylic acid gives test with all Na, NaOH and NaCO3, while alcohol doesn't give any test with NaOH and NaCO3, only reacts with Na. Phenol can react with NaOH and NaHCO3 but doesn't react with Na. No, doesn't react with sodium bicarbonate but reacts with Na and NaOH. And similarly, alcohol only reacts with Na, doesn't react with NaOH and NaCO3. Then we have test of amines. So guys, amines are further classified into three categories: primary, secondary and tertiary. I taught you in the GOC chapter. Now you can relate which amine is reacted to where. So aliphatic amine, if we react it with the nitrous acid, HNO2, aliphatic is RNH2. RNH2 gives you nitrogen gas, and nitrogen gas is evolved if we use 1 degree aliphatic amine. If we use, this is the reaction given. If aromatic amine we use, diazonium salt is formed, which upon further can release N2 gas, but it is stable up to 0 to 5 degrees Celsius. Now add the cold diazonium solution, swilling to a cold solution of 2-naphthol. So naphthol, and which is an organic compound, naphthol, phenolic functional group, in 5% NaOH and 2 ml, orange red azo dye is formed. Okay, so this is a dye formation we can see. We'll study about it, and this kind of coupling reaction will be seen in the chapter called as amines. Secondary aliphatic yellow oily nitrosoamines are generally formed. Okay, nitrosoamines you all know, like this. NO group is added. I told you, no, NO2 group is added in the place of hydrogen. And that's why tertiary do not give any test. Tertiary no visible reaction. Dialkyl anilines yield green solid. That's different reaction. Third, tertiary, if it is a tertiary amine like this, so this is dimethyl or dialkyl amine aniline. It yields green solid para nitroso compound with this reaction. So if you react with this HNO2 reaction, then it gives you a para nitroso compound. This will be nitroso NO, and this will be same only, and this is green in color, green PPT. Then we have Hinsberg test. Hinsberg reagent is benzene sulfonyl chloride. So whenever we react benzene sulfonyl chloride with 1 degree, 2 degree, 3 degree, some reactions occur like this. So 1 degree reacts here, some nucleophilic kind of addition reaction is happening here. See, it goes there, attacks here, goes here, come back, Cl is departed, it forms an HCl with this compound. Now since this compound has a acidic hydrogen, upon reaction with, this is called as N-alkyl benzene sulfonamide, and this is insoluble, which upon reaction in acidic medium produces a soluble compound. Secondary doesn't is insoluble in base. This is soluble. Okay. This part is soluble in NaOH because of the acidic hydrogen. But no acidic hydrogen. See, in case of second degree amine, we have no acidic hydrogen in N-dialkyl benzene sulfonamide. This is N-dialkyl benzene sulfonamide. So no acidic hydrogen. So insoluble in NaOH. What about the tertiary? Tertiary won't even react with this because there is no substitute, no hydrogen is there to substitute as HCl. Then another reaction is there, the reaction with carbon sulfide CS2. Carbon disulfide reacts with primary amine to give you a compound with the formula NHCSH, and it reacts with base because of the presence of this acidic hydrogen. Secondary amine react with CS2 but do not give any test with the base, and tertiary don't even react with CS2. It's that simple. Then we have carbylamine test, everyone. We use chloroform and alcohol, chloroform and KOH here, aqueous KOH only, and the compound formed is RNC, which is alkyl isocyanide, or we also call it carbylamine, which is bad or foul smelling compound. So it confirms the presence of NH2 or amine group, but this test is only given by the primary amines. Primary alkyl or primary aliphatic and aromatic, both amines can give this test. Secondary, tertiary do not give this test. Next is azodite test. Azodite test is actually a coupling reaction. So 1 degree amines on heating with NaNO2, they form the benzene diazonium chloride. The diazonium salt on coupling reaction with beta naphthol gives the orange red color dye. So dosto, I told you it will be learned in the coupling reaction, will be taught very soon. This entire upcoming month of December will be highly dedicated to our organic chemistry only, and I'll try to finish all the remaining chapter of your organic chemistry: alkyl halide, aryl halide, haloalkane, haloarine, and then alcohol phenol ether, carboxylic acid, aldehyde, ketone. We have so many chapters are remaining, man. So these all things will be understood by that time only, because right now you might not be able to connect with them, right? This, especially this reaction of amine, and there the reaction of amines are going on. Then we have amides. So how amides can give a test? So simple primary amide, guys, these notes are highly self-explanatory. So the moment I'll provide you the notes, you can just download the notes, start making your own short notes. Every single reaction must be there on the page. Make just a single one step page, one front and back page, and just learn it. This is the only key of revising it properly while your exams will be on. So guys, try this. We have amides. Simple primary amides can be decomposed by boiling with alkali and thereby evolving ammonia, which has a pungent smell. Okay. So CH3CONH2 is a compound which is amide, and on base reaction and then on heating it produces what? It releases ammonia gas. Then we have Hoffman rearrangement. So Hoffman rearrangement also we call it, or we also call it Hoffman bromamide reaction. Very important reaction. Hoffman bromide reaction. Then we have ester detection, ester COR group. One test is called as hydroxamic test, where CrCOR is the reaction with NH2OH called as hydroxylamine. So this forms RHRCO instead of OR. This has replaced it like this, and this will be replaced, and it gives you a rise of let's react with this in presence of sodium hydroxide to form the sodium salt of corresponding hydroxamic acid. This is called as hydroxamic acid. And on acidification with the addition of ferric chloride or magenta color is obtained. Next is hydrolysis test. Simply hydrolysis will give you ester on hydrolysis gives you acid and carboxylic acid and alcohol. Next we have, so undergo hydrolysis with NaOH, and the compound formed is heated with NaOH, which is actually your alcohol. No yaar, I can't relate. Esters undergo saponification reaction, hydrolyzed NaOH. The compound is heated with NaOH with a small amount of phenolphthalein. Okay. The initial pink color of the solution is discharged due to the formation of an acid. Since the phenolphthalein shows a pink color in the basic medium, the color is medium. Then we have detection of nitro group. Nitro group detection is done by two tests. One of them is called as Mulliken test, another is azodie. Mulliken test, we are conducting the experiment of reduction where NO2 is converting into RNHOH plus H2O. Okay. So the nitro compound is dissolved in alcohol and is reduced with this, and this reduced with this, and then it is boiled. And it's filtered, cooled and heated with ammonium nitrate that gives this test. Okay, it's okay. Then we have azodie test. Aromatic nitro compounds are first reduced to NH2 by SnCl2 and zinc. Concentrated HCl and SnCl2. And then Stefan's reduction. We call this reaction Stefan reaction. On reaction, so basically you will understand these when this particular part of this chapter will come. Otherwise, it is not that easy to understand. Similarly, these tests will be studied in biomolecule, like Molish test of carbohydrate. Felling's test is also done for non-reducing sugars, and osazone test is for ketones and aldose react with phenyl hydrazine to produce the phenyl hydrazone, which upon reaction with another two molecules of phenyl hydrazine yields the osazone. Yeah. Then there are some tests related to the protein. So read them out, everyone. Yes, I will definitely share the plan, no problem. I'll share the plan with our coordinator and you will receive the plan very soon, everyone. I have a scheduled lecture by 5:30, so I will have to wind up the class now. And these are some tests I would expect you people to learn. Not too much, it's very simple. Alkane, alkene, alkyne test already done and conducted. And I'll teach the all reactions in hydrocarbons chapter. Then whenever we'll be dealing with the biomolecule, I'll let you know about these tests. But these tests are actually not present in biomolecule also. Yes, try to learn over here only. Protein gives this type of test where ninhydrine, then we have xanthoprotein test, then we have millions test, and then we have burette test. Anyways, let's try some questions, okay? Let's try some questions now. The final part of this chapter. Among which of the following which will give you the positive iodoform test on reaction with I2 and NaOH? So the one which contains, I told you, methyl keto group or secondary hydrogen with alcohol. This kind of alcohol will not give you the test. I'll directly handwrite the answer here. This is the correct answer. See? pH C double bond O, no, CH OH CH3. See, this is the group I was talking about. This will give you, and this will be converted into CHI3. This will become COH, that is oxidized form. Identify the hydrocarbon with molecular formula C5H6 that gives a white PPT. So white PPT can be given by terminal alkyne. Terminal alkyne, if we are talking about the hydrocarbon, only hydrocarbon that can give this test is terminal hydro. This can be done. So this is incorrect and this is also incorrect. Now out of these two, let us try the formula. So 1, 2, 3, 4, 5. This is C5, 3, 4, 5, 6, 1, 2, 3, 4, 5. 3 plus 2, 5 plus 2, 7, 7 plus 1, 8. C5H8. Man. And here it is C 1, 2, 3, 4, 5. C5 H 3, 4, 5, 6. C5 6. This is correct. A is the correct answer. So somewhere we have to use formula also. That was very basic. Which of the following compound will give you a positive iodoform test? Again, very easy question. Try it by your own homework. Next is, which of the following compound will give you distinguished by which of the tests? Okay, distinguishing. This is normal alcohol. So, and this is the COH group is in both. So no, both. I'll write in terms of like which can give which test. So this is given by first and second. Neutral efficiency by phenolic group, so only second. Then blue litmus solution, acid is in both first and second. Blue litmus will be converted into red because both contains the acidic group COH. Sodium metal gives reaction with all, first and second. Okay, one more is there. HCl and ZnCl2, it gives the reaction with alcohol only. So this will be given by first, not by second. Now tell me, which can give distinguished by, I think E and B. B and E. Second is correct. See how easy the questions are. Right? Am I hiding the questions? Should I get an aside? Yeah, I should. So second, primary and tertiary can be separated by carbylamine also. Only carbylamine is fine. So that's it, everyone. That was the wonderful day we had, and you all can download these very precise and very self-explanatory notes from our channel. So just subscribe us, everyone, and like the session if you have liked it. Download the notes from our Telegram channel. The link is in description. Sir, where will I get? Sir, please respond. Yeah, man. What happened, Om? Let me check your message, man. Sir, where will I get the schedules and timetable of the lecture that happens on this channel? Okay, I will make first and then I'll share it with the coordinator and he'll post it very soon as a community post. Don't worry. I got your message. I'll ask my like channel coordinator, Mr. Sachin Saraf. He will post you as a like this month's plan. He'll post you. Okay, but probably the upcoming sessions will be uh, like happening in till the end of this month only will be happening from here. I have some family functions and some family emergencies to attend with. But the moment I come back, I promise you in this entire December month will complete not just the organic chemistry but also will revise so many concepts. And believe me, I'll bring so many good things, most expected questions I'll bring, and believe me or not, 40 to 50% you can match directly in an exam from my challenging questions. This has happened in previous years also. Earlier I was teaching on so many other challenges on Unacademy items and Academy JEE. You can find and you can check. You can go and visit my videos, these non-stop videos. But anyways, I'll come later and I'll provide the complete completion of this entire chemistry, and along with that will do some practice of the PYQs and some important questions also. So I think that is it for the day. Thank you, Om, for your love and your response. And everybody, just stay tuned and just like the session and subscribe to us so that you can be very much sure you can be updated about our upcoming videos. Bye bye.